Hi everyone, welcome to this new video. Today we will be building a 2D portfolio project. So it's a 2D developer portfolio, but as a 2D game. And without waiting much further, let's jump right into it. So this is what we're going to build. You can move around a house, and then as you approach objects, you can have a text box that tells you a bit more about yourself. Here I've selected some text. For example, here there's my CS degree. This is my CS degree. I hanged it on the wall because I'm proud of it. And then if you move around, you go here. You have a place to have your resume. You can click. If you click on that, it will open a link with your resume hosted here. For example, this is just a template. So this is the idea behind the project. Here you have a bit of text. So it's an original way of making a software developer portfolio. I've seen a couple where it was in 3D, but nobody seems to have made in 2D. Actually, there were some, so I thought I would just teach you how to do it. What's interesting here is that we're going to build this project with JavaScript and the Kaboom.js library. So Kaboom.js is a library for making games in JavaScript. It's very easy and intuitive. But also for all that is the text here, the text box, the text here as well, this is all HTML and CSS. Here, because the reason is that for this project, everything should be interactable with the mouse or the touch screen. So if I open the DevTools and go to the mobile view, and then here, you should be able to move around, and the text therefore should be responsive. So here, example, you have a text, and that's it. So you can close. So for this to be achievable, for the game to work on all aspect ratios, it was important for me to make the UI portion of this project in HTML and CSS. So let's jump right into the project. But before we do that, I just want to mention a few things. So if you're interested in having written tutorials, you can go to my Substack. The link will be in the description below, where you can have written content that explains specific concepts. So on YouTube, I make full-length project tutorials, and sometimes you just want to know how to do one specific thing. So the Substack here, my newsletter, is for that. So here, for example, for this project, it's going to be relevant to know how to implement 2D top-down controls for a mobile web game. So here we go. You have videos here that just showcase the results. Another thing I want to mention is just to showcase my Buy Me a Coffee page. So if you want to support the channel, you can buy the support with $5 a month and with this tier, and you get access to this tutorial you're currently watching and all the future tutorials in advance, so early access. You also get early access to the source code and some progress updates as I do them. So if you're interested in supporting the channel so I can focus more on making tutorials, feel free to contribute here. You can also just leave a normal tip if you want. All right, so let's jump right into the project. So I'm going to use for this project VS Code. It's the editor I use mostly for everything. And here we're gonna need a few things. So let's start our project. So I assume that you know how to use VS Code at the basic level. So you have it installed on your computer. You also have it, you have Node.js installed also, which is going to be important for this tutorial because we're going to use Vite. Vite is a bundler that allows you to write your JavaScript in a more convenient way. So we could use script tags as we did in a lot of the previous tutorials, but with Vite you get you can install your dependencies by typing in npm install, and it's just more convenient in a certain sense. And you will also get auto completion and snippets, code snippets from the Kaboom.js library that tells you this is this feature, what it does, which is something you don't get if you just use a script tag. But feel free to follow using only a script tag if you want. The setup sections of previous tutorials are going to teach you how. So yeah, I'm just going in this specific tutorial, I'm not going to spend a lot of time on this. So the first thing we're going to do is to type npm create vite at latest. And then dot, because we want to create the project within the same folder we're currently here in. So here it's 2D portfolio. So I hit enter. And then we should have something appear. Need to install the following package. Yep. And then here it's going to ask you to select the framework. We're going to go with vanilla JavaScript. And it's going to add a bunch of stuff. So for now, just do npm install Kaboom. So it's going to install the Kaboom.js library. Whoops, I hit the wrong thing, but hit enter. Is it going to work? Okay, all right. So it's going to install the project, and then in your package.json, you can see all your dependencies. So here we have a Kaboom. All right, now the rest of the project, we're going to need to set a few things up. So the first thing we're going to set up is I'm going to remove a lot of the boilerplate you see here. I'm going to remove main.js. I'm going to remove counter.js. I'm also going to remove this. And within vite svg, I think it's not needed as well. So this, remove, and also the style.css, we're not going to need it for this project. So delete. Okay, now once we have this, let's create a few folders you're going to need. The source folder, src. This is where we're going to write our code, our JavaScript code. We're also going to need the public folder. I deleted it by accident. I wanted to just delete what was in the public folder. And we're going to create at the root of the project a vite config.js file. This is going to be useful for a specific reason. We want to be able to export. So the way a bundler works, it compiles your JavaScript. So the Node.js JavaScript that you write and the JavaScript that runs in the browser is not necessarily this exact same thing. So this bundler basically transpile or compiles your JavaScript to a JavaScript version, or it's a bit hard to explain, to a version of JavaScript, not a version, to JavaScript that can run in the browser as is. So yeah. Now the reason for this is that a lot of features were not supported in the past in the browser version of JavaScript, while in Node.js you could have things like convenient things like using import statements, but now import statements are actually available in JavaScript in the browser. So that's how I've been doing the various projects you've seen on the channel, if you're familiar, in the past tutorials. So in the vite.config.js, we need to specify certain things. So just want to clarify again that not only does a bundler transpile your code, your JavaScript code, so it can run in the browser, it also do optimizations, minification, so that your code is really compact and takes the least amount of space. All right, so here I'm going to do export default and then define config. This is coming from vite, so it's going to import it from vite here. And then within, we're going to have to specify the base. So the base here, when we run the npm run build command, which is used to do the transpiling and gives us the actual code, that is going to be used, that you actually put on your server or on itch.io to have your website up. We need this base thing. Otherwise, it's not going to be able to find the assets, for example, the sprites we used with Kaboom.js. The second thing we need to specify is the build. And here, the minification, we're going to use something called Cursor instead of the default ES build. So the reason for this is due to Kaboom. There is a bug with the way Kaboom is made, that if you just use the default, it's going to give you code that doesn't work. The actual output will no longer work. So that's why we need to install this alternative called Cursor, which is going to make our code Cursor, so smaller, minified. So once this is, I should have installed it as a dependency. So npm -d for dependency, install Cursor. I think that's the command, or if it's not that, it's going to be the reverse. All right. Now, if I look at the package.json, you can see that as a dev dependency, we have added Cursor. Okay, we have everything we need. So now I'm going to create a main.js file. And in the index.html, we're going to have to do a couple of things. So I'm just going to remove that. So the first thing we need is to create a style tag within the body. This is where we're going to write our CSS. Now, you could have decided to use an external CSS file, but because this project is not really CSS heavy, it isn't really that necessary. The second thing we need to modify is here, the script tag that imports the main.js file. We need to actually modify the path to be source, like that, because we have created the source folder in which is our main.js file. Okay, now in the div, we actually can work this out later, but actually, never mind. Here, we're going to create our canvas that we're going to give the control of it to Kaboom. So I'm going to call it game. The ID is going to be game. And here, we're going to have a div that is going to have the ID of UI. I'm not sure if I'm going to use this later on. I might just remove this ID, which just is going to contain everything that is the UI. So the text box and text. All right. Now that we have this in our source folder, I'm going to create a file. This file is going to be called Kaboom context.js, so CTX to abbreviate it. And this is where we're going to set up Kaboom. So I'm going to use import Kaboom from Kaboom. This is possible because we have installed Kaboom.js. And you can see that there is a difference in the way native JavaScript that works in the browser deals with imports and how this Node.js version of JavaScript works. So if we were to use the native JavaScript in the browser with modules, you have to add the .js for the file extension you want to import. But this is not needed when you're using a tool like Vite. Okay, so here I'm going to create our canvas, our Kaboom context, which is going to be unique. And through that object, this K, we're going to call all the functions we need. So we're going to pass this around in our project. I think this allows us to have cleaner code as the project grows, instead of having to importing Kaboom globally, where all functions can be called directly from anywhere. So this is a pattern I recommend that you use for your Kaboom.js projects. So when you create the Kaboom context, you need to pass a few params. Actually, you don't need to pass any params by default, but if we want to achieve the thing I said about not making it global, you have to pass in the global property and set it to false. Then here, this is going to be relevant for the fact that we want our project to work on mobile as well. So we want to have the touch to mouse property, which again is from Kaboom, and set it to true. It's going to translate all touch events on the phone to click events, so that you can basically write your code with the mouse in mind, but it's going to work just as well with mobile. And then finally, we can have the canvas property, where we're just going to give to Kaboom the canvas element. And the way we're going to do that is by using document get element by ID. And here we give it the game ID. If you remember in index.html, we gave to this canvas the ID of game. So we're just telling Kaboom, here, take the element, take control of it, and do whatever you want, whatever you need. Okay, so now that we have this, everything is fine. And in main.js, we can start writing our code, but before doing any of that, let's create all the other files we're going to need. So constant.js, it's going to contain, as the name suggests, constants, which is also going to contain the specific dialogues and the scaling constants, etc. And then finally, we need the utils file, which is going to contain a few functions that just to make our code look nicer. So in this project, it should not take too long compared to my previous projects. So yeah, if you could have made everything in just main.js if you wanted. All right, so now in the public folder is actually where we're gonna store our assets. What I need you to store is the font monogram.ttf. You're gonna find this in the link in the description of this video. If you're an early member of the if you're watching this in early access, you should have also a link. I'm either going to drop it in the post or in the actual video, so you should it should be obvious where to get it. And now we're also going to need the sprite sheet that we're going to use for this project. This is the sprite sheet. The link is in the description as with the text. And then finally, we're gonna use an external program called Tiled to draw our maps. But for now, let's just keep those two things. And then in main.js, let's actually start writing our code. So I'm gonna import the context from Kaboom. And here the first thing we're gonna do is use the load sprite function. It's a function that allows us to load an image as a sprite. And then we can specify a bunch of frames. So here I'm giving it the name of sprite sheet, and the second param should be the path where to find it, and it's going to be sprite sheet.png. Now, the reason this is just ./sprite.png, despite the fact that it's in the public folder, so normally you would think that it would be / and then public / spreadsheet. But the way Vite works is that you can assume that everything that is in the public folder can be directly accessed like that. So this is something specific to Vite. Now the third param is going to contain a bunch of properties that tells Kaboom how to slice the image into various frames. The first two properties is the slice x, so how many frames are on the x-axis. Here 39. How did I come up with this number? I just counted the number of frames, the number of frames here. You could do that with tiled as well to give you the number. And then this is something you should know. So for example, each of those is each frame in this image is a 16 by 16 tile. And that means you can know roughly, like, if you take the length of the image, which is here 624, and then you divide it by 16, you're going to get the number of tiles or frames that are going to be on the x-axis. So you can manually calculate it with math. All right, slice y is going to, again, describe the number of frames there are in the y-axis. The same logic can be used to calculate it. So knowing that every frame is 16 by 16, this is the way this sprite sheet is designed. You can just take look at the height of the image in the properties or here in VS Code on the bottom right corner, and you divide that number by 16 and you get the number of frames. All right, now here comes an interesting part. It's called the anims property. And here it's where you hook up specific names to specific animations. So here, the idle down animation for our character is just going to be one frame, and it's going to be frame number 536. Now, how did I discover this? It's by using a program called Tiled. This program is called Tiled, and I think it's actually a good time to create our maps, basically create our map. And while setting things up, we're gonna see how I figured it out. But just to be quick, you click here on the frame you want, and then you get the ID, so the number of that frame. Now let's assume you don't have any knowledge of Tiled. So install Tiled by using the link in the description. Once you have it, you should have this editor. Let's assume you have a new project, so I'm just going to create a new map. And then let's, I don't remember the dimensions I've used, but don't touch anything here except specify the width as 16 pixel, the height as 16 pixel as well. As for the map size, make it fixed and then take these numbers by default. All right, we have the map here. Now, another thing you can do, because if you're using tiled on a wide monitor, for example, things might not be clear. So you go to Edit, Preferences, and then in Interface, actually it's in Theme, you check Use Custom Interface Font, and then you can select a specific font and then increase the font size. This is useful for you to be able to clearly read things. Once you have this, in the map, you can go to, I think it was map properties, actually maybe not. A world, okay, in view, snapping, no snapping for this project. If you clicked on snapping, snap to grid, it's going to make sure that everything fits into a grid pattern. I think for tiles, it's in grid pattern regardless. But if for the collisions box we're gonna draw, we want to find more fine-grained controls. So that's why I deactivated it for this project. Okay, now add a new tile set to the right. Okay, now browse where you've put the sprite sheet in your project and link it here. So this is it. So for the path should be here. And then this is specific to me. So for you, if it depends on where you put it, the actual project. And then just don't touch anything. The tile width and tile height should be 16 by 16 pixels. And then hit OK. And now you have the sprite sheet. So a good thing right now would be to save the map. So go to the file, save as, and then name it map.json and put it in the public folder of your project. All right, so you can see that I've named it map.json. This is the name I want you to use. And it's going to basically create a JSON file in your public folder. So if I minimize this and go here, you can see that we have map.json. This is important because this is how we're going to know where to draw the hitboxes and where to draw certain things. So if I go back to tiled, for now, we only care about knowing how I figured out the 936. So here it is. 936 comes from the end. As you click on the various other tiles, you can see the various numbers. This is how you can know which frame is which. Okay, now I'm not gonna copy paste. I'm not gonna write the code for this. All the animations we're gonna use by hand. It's gonna take too much time, so I'm just going to copy and paste it here. So here we have the idle down animation, which is just one frame. With the walk down animation. So how do you specify animations with more than one frame in Kaboom.js? You use this an object. You pass in an object with the from property, which is the starting frame, the to property, which is the finishing frame, and whatever or not you want to loop. This is not mandatory because by default looping is false, but we want the animation to loop always, and we decide when to stop it and when you cancel it. And then the speed is the frame rate. So here 8 frames per second for this. So we have 4 frames in this animation. So a speed of 8 is what looked good. So if I go back to tiled again, you can see 1, 2, 3, and 4. This is how you know. This is how I knew it was 4 animations, 4 frames. Sorry. And then here it's the same thing, but with the various different directions. So here for the sideways, we only need to have one of them. I think we're using the right one by default. Yep. And we're just gonna flip it over when we need to make the character look left. All right, so now that this is done, I think we can just start drawing the map. So I'm gonna open tiled again. Now here, I really want to have the same thing, but yeah, this is always a difficult part of the project where I just want to copy the map layout instead of doing it manually. But just to teach you, so what I'm gonna do is I'm gonna teach you how to make a watered down, like very simple version of this map, and then you just take my map.json file here and you use it. So the map.json file that I used in the project, in the actual project, is going to be in the description, and this is just a tutorial version that you can just swap out. So this is just to teach you how to use tiled. So once this is done, I'm just gonna use the actual real map.json instead of writing the code as if. Anyway, all right, you get the point. So just to teach you the way you draw things. So let's have, okay, the way layers works. So I'm just gonna, this is just a small crash course on tiled, how to draw maps. And yeah, so by default, you have things called tile layers. So tile layers are layers that contain tiles that you can draw. There's another type of layer called the object layer, which contains collision boxes or spawn points, which is basically needed to know where to set where the collisions are, etc. So let's say we have this first layer called ground. So you decide on the name, and depending on the name, the resultant JSON file that you save is going to contain those names, so you can know which layer is which. So here, let's say I draw the ground like that. So I drew a couple of tiles. Everything looks great. Now, if you want, you click on this button to add a new layer. Let's say I add another layer, and I'm just going to call it plants or props. And then I can draw on top of it like that. And that's basically it. That's how you draw a map in Kaboom, not Kaboom, in tiled. Now, when you want to add collisions, what you do is you create an object layer, call it, for example, boundaries. And then here at the top, you can have access to those shapes. And then here, for example, a square. Let's say I want the player not to be able to escape outside this little square. So I can do here and then draw a grid like that. Here it's often better to have the snapping set to snap to grid. If I do that, it's going to be very easy to make perfect, pixel perfect collisions, boundaries. But now if I go back to here, snapping and no snapping, and I want to draw, for example, for this tree, this specific shape, and then this specific shape. So you have more fine-grained control. And now this doesn't do anything on its own. It's just for you to know that, hey, there's this layer called boundaries, and it's going to be an object layer. And this is what, and when you're using an object layer, each object you create in that layer is going to have the X, Y coordinates and the width and its height, so you can know what to draw, where to draw the hitboxes when you're working in Kaboom or in JavaScript. You don't have to use Kaboom to use tile, by the way. Now the other thing I want to talk about, it doesn't have to be a separate layer, but let's say we create a separate layer, and I'm gonna call it spawn point. Not spawn point. What is this name? Anyway, spawn point. And then here you can use this pin, and when you place it, it's gonna basically create a coordinate that you can use as a way to know where to spawn the player, for example, or NPCs or mobs, etc. So this is how tiled works. So once you're ready with this, you just save it. Now another thing I want to showcase is that this is not enough. What we want, so this is something specific to Kaboom. So usually by default, it's better to draw normally in JavaScript or in any like programming language. It's better, like it should be more efficient to draw the frames tile by tile instead of like having an image that contains all the tiles. But in Kaboom.js, it's different in the sense that it is more performant and easier to maintain if you just go to your tiled editor and do export as an image. So what this is going to do, it's going to combine all of your tiles here as a single image. So if only include visible layers. So before doing anything like that, you need to make the spawn point and the object, the boundaries layer invisible. Otherwise, it's going to appear in your project. And then you save, and then you go to File, Export as Image, and then you export, only include the visible layer. You don't touch any of those things, and then export. Now here, if I go in my code editor, you're gonna notice, you're gonna understand. So map, you see all the image is baked as a single one. So here we go. Now this would be inefficient or less efficient in other libraries, etc. But with Kaboom, because when you create new tiles, you create new game objects, it can be because game objects in Kaboom.js, you create things called game objects, which are usually your player, your tiles, anything. And when you do that, it is performance intensive because every game object has a few components. Those components do some stuff, etc. So a way to get around that, not have to do this or pay the performance tax that comes with it, there are many ways you can adopt. The simplest one is just to bake your image, take your tiles and just combine them into a single PNG and just draw that as is. Now the tiled export is still useful because in tiled you're going to have this map.json, and then for layers that aren't tiles, you get the object layer and the position of the hitboxes, which is still valuable information you're going to need to draw the hitboxes in your map. Otherwise, the other option would be to use the onDraw function in Kaboom.js to draw the tiles specifically without having to create a new game object. But it's just more complicated it's a better alternative, but it's just more complicated. And for this project, I just opted with just taking a single image, using a single image. Yeah. Okay. I think I've taught you everything important related to how to draw things in Kaboom, in tiled and etc. Now, what we're gonna do is I'm gonna swap the files here. I have the map.json, map.png with the actual maps. So you can see, actually, the one thing I realize now is, never mind, you still need the spritesheet.png because it contains our character, and the character sprites are directly pulled from that image from Kaboom. From that image are pulled the sprite character, so Kaboom still needs that. But for the map, for all the other types, so you could theoretically remove everything else and just keep that, and it would have been more efficient, considering that when you're making a web game, you have to see how much data you're sending. But those images are already very small anyway, because it's pixel art. Okay, so I'm gonna swap my images, my map, and my JSON file with the one I originally used. And now if I go and look at the map.png, you can see like the exact same map. And if you look at the map.json, you can see the various tiles. So let's take some time to explore how what the map.json, what the tiled export contains. So the thing that is very important is the layers property. So tiled exports with a bunch of properties, most of which are useless for our purposes, but the one that is useful is the layers property. So if the layer is a tile layer, it's going to contain the data property, and it's an array containing the frame number that needs to be displayed. 0 is the absence of a frame. For object layers, though, it's different. They don't have the data property. What they have instead is the objects property, which is an array containing every object that you've drawn in this layer. So the most important stuff is the x and y coordinates and the width and the height of that object. So this is useful for the boundaries. All right, so we have our map.json. Everything is fine. Now let's load our, just one thing I want to mention as well. If you want to add to a boundary, So this is often something you want to do. You click here to select an existing object when you are on the object layer. This little icon. Ignore this message for now, and then you can modify the width and height, etc. But you can also here in the properties tab add a name. Let's say I want this boundary to have a specific name. Let's say wall. And when the player hits this, we're gonna know that it was a wall. So you can use the name, the data you pass here in Kaboom.js to know what the player is colliding with. So now I'm just gonna close this. It's no longer necessary. I'm just gonna discard it and go back to my original. So here is a bunch of objects that I've named specifically, like CS degree, PC, sofa table, player, TV, exit, etc. And for each of those, we're gonna have a different dialog appear. Okay, so let's go back to main. And in main, what we're gonna do next is to import the actual map sprite, which is a single PNG image now that we have baked it into a PNG instead of drawing every tile separately. And then for the background, the way you can set the background in Kaboom.js is using the set background function. If you use this though, you need to pass in a color, and the way you can pass color is either via RGB, or you can use the color class and the from hex method to specify a hexadecimal value. The hexadecimal value we're going to use for this project is 311,047. And now if I run the project, so let's run it. I'm going to open up the terminal, type in npm run dev, and then once you do that, you can click on localhost, and you should have your canvas. So here we haven't done anything yet, and things aren't looking great. So we're gonna have to change the width of the div containing the canvas so that it takes the full screen. So you know what? Let's do this before actually writing the code, etc. So let's go back to our index.html, and in the style tag, I'm gonna add a couple of styles. So for the app div, so here take the IDs, and then we're gonna specify a width of 100%, so it takes the full width of the page, a height of 100% as well, not 10%, 100%, and then overflow hidden so that scroll bars do not appear ever. We don't want scroll bars to appear in this project. If I look at the result, you can see that the canvas takes the whole space. Okay, now let's go back to main.js and then create our first scene, which is going to contain all of our code for that specific scene. I just want to make sure that for this project, because we don't have multiple different scenes, it isn't needed to create a scene, but I just want to show you how it's done in Kaboom.js. So to create a scene, you use the k.scene function. You give it a name. I'm going to call it main. And then what comes after is a function, which is going to be the code that is going to run for that scene. So here's where you write your logic for that scene. But before doing any of that, you need to specify using the k.go function what is the default scene. So by default, the game starts, it goes to the entry point main.js, it loads the various assets, set the background color, defines the scene, and then go to that main scene. Now here, this function we passed here is we're going to need to have it as an async function. The reason for that is because we're gonna need to get the map.json data, and for that we're going to use a fetch call. So const map data is going to be a constant I'm going to name to basically get the map.json data we need in our JavaScript project. So here I'm going to use await fetch, which is a default web browser API. I'm going to explain everything in an instant. And then here.json. So here in one line, first we await the fetch function because it is asynchronous. That means that if you were to not use await, then your code, the rest of the code would continue to execute. So let's say I have some logic here. It would continue to run while fetch is still ongoing. We don't want that. We want to load the map data and not move the rest of the code here until it's done. That's why we await it. So basically waiting it. And then once we do that, we also need to convert it into a JSON object. And for that, we need to use the .json function, which is also asynchronous, .json method, which is also asynchronous. That's why we need also to await so that we don't move to the next line of code before it's done. So once map data is done and ready, we move on to the next things. So here I'm just going to create another constant called layers, and I'm going to extract from map data the layers property. So if we look at the map.json file, you can see that the properties, that one of them was layers, and this is really what we care about. That's why we create a constant. This is just for it to look cleaner. You didn't have to create a constant to get it, but yeah. And then here we're going to create our first game object, which is going to be our map. So in Kaboom.js, a game object can be basically everything, players, props, etc. What is a game object exactly? It's an object that contains different components. Those components can be positions, area, a body, or a specific sprite. And the way Kaboom works is that by passing in an array of components, you specify behaviors for your game objects. So it's basically an entity component system, I think. So how do you create a game object? There are many ways, actually two. The first one is the make function, which allows you to create the game object but not display it on the screen. The add function adds it to the scene. So either you have a choice. Either you make it and then later on you have to call the k.add function and pass in the game object like that, or you use the add function from the get-go and pass in your array of components here. So for the map, what components are we going to need? We're going to need to the sprite component to display the sprite, the actual map. The way we do this is simply by using the sprite component, which is offered by Kaboom, and passing it the key for the sprite you want to display. We specified the key in the load sprite function for the sprite for the image map.png. That's how Kaboom is able to know in advance what to display actually. Now the next component we're going to add is the positional component, and it specifies the position that the game object will have on the screen when it is displayed, and here it is 0. Well, it's not necessarily only when it is displayed, just the position that it could have, regardless if it is displayed or not. And then if you use the add function, then it's going to draw it in that specific place. And then finally, we're going to need the scale component, and we want to scale up our map because it's pixel art, it's small, and we want it to be bigger. So a good practice I'm going to do is in the constant.js, I'm going to create a constant, exportable constant. I'm going to call it scale factor, and I'm going to set it to 4. So we want to increase it 4 times. And then in main.js, I'm just going to use that scale factor constant and call it. So it should automatically import the scale factor constant in case it doesn't add this at the top of your file. All right, now the next game object we're going to create is the actual player. And for that, I'm going to create a constant. I'm going to call it player. I'm again going to use the make function here. And the sprites we're going to pass is the sprite sheet itself, but with a default animation. This is something you can do when you have imported a sprite that has many frames, so a sprite sheet. You have access to this second param where you can specify a default animation, and here it's going to be idle down. Now the second component we're going to need is the area component. This creates a hitbox for our player automatically, and within you can add, so it's not very visible, so I'm just going to format this myself and then explain. So the k.area component allows you to create a hitbox automatically for your player, for your game object, but you can specify things within by passing in an object with the following properties. You can specify which collisions you want this game object, so the player game object, to ignore. And I want to, actually this is not necessary. We don't need that. This because in the project I did it a different way initially, but then I found a better way which doesn't require to really need that at all. But what we do need is to specify a shape. So by default, it creates a shape that is roughly the shape of your sprite, but sometimes you want really to control the shape of your hitbox exactly. And the way you do that is by passing in an object with a shape property, and then you use, for example, k.rect, which is going to create a rectangle. And then the first param is the position, which is a vector 2. A vector 2 is x and y coordinates. And you can specify here the vector 2 is going to be 0, 3. So we want the hitbox to be drawn from the origin and then +3 on the x-axis from the origin of the player itself. So the area is going to be placed slightly differently than the sprite itself, so that the hitbox is positioned properly. And for example, the player doesn't look like they are sinking in a platform or something like that. So this is something you have to play with yourself to determine which values are the best. And now the second and third params are the width and height of that hitbox. I'm going to go with 1010. It is on purpose smaller than the player's sprite, which should be 16 by 16. Now k.body, make sure is another component that actually makes our player a tangible physics object that can be collided with. And yeah, that's basically it. It's done automatically by Kaboom. Now we can also use the anchor component to draw the player from the center instead of from the top left corner. So this, the way things are drawn by default is that the x and y coordinates are actually the coordinates of the top left corner of the object you want to draw. If you don't want that, you want the x and y coordinates correspond to the origin, you use the k.anchor and then specify which, so from the center. Now it's not the x and y coordinates that are in the wrong position, it's the where the image is drawn from. So that's something. So for example, so the player, instead of being drawn from the top left corner, where the top left corner of that image will be the x and y coordinate of that player, it's going to be the center, drawn from the center. So feel free to try and change the values or just try without, and then hit the F1 key to open the debug mode in Kaboom.js, and then you can see the difference. All right, now we need a k position component. We aren't going to specify a specific position now. We're going to do this later when we're getting the data from our map. We're going to use this spawn point. So here, if I go back to tiled, you can see I created a layer in the original called spawn points. And it's just this little pin with the name player, which determines where to spawn So if I click on it here, you can see I've decided on this name. I just wrote it here. And then it's going to give us the X and Y coordinates. So we're going to know where to place the player. All right, another thing we need to do is to scale the sprite for the player, because for now it's going to be small. It's going to be a 16 by 16, and we want it to be at least the same, scaled the same as the map, so that everything looks right. And then finally, well, not finally, but we have what comes next is in Kaboom.js. If you want to hold properties for that game object, you can pass in your array of components an object, and then put whatever properties you want, and then they're going to be accessible directly by doing, for example, player.speed. If I create the speed property here, I'm going to put it to 250. I'm also going to create a direction property that's going to be useful to know which animation to play. By default, it is down. And then is in dialog property, which is initially is false. So why we want this is that when the player is in dialogue, that means that the text box is displaying text. We want to prevent the player from being able to move or do anything except read the text and click on the close button. All right, the last thing we're gonna add to that game object is the player tag. So the way, actually, I'm not sure it's going to actually be useful for this project, but I'm just gonna add it for now. It's when you want to check for collisions. If you give a tag to your game object, you can then use the onCollide function to know, okay, this collided with that tag, and that means to run this type of logic. So it's a way to identify your game object. All right, so if I look at the result, nothing yet, of course, because we haven't put anything. Now that we have the player, etc., let's write the logic for actually displaying the boundaries. And then as we write this, we're going to write everything else we need. Okay, so here we need a for loop, which is going to iterate through the various layers we had here. And then depending on the layer, so if the layer dot name equal boundaries. So if we are on the boundaries layer, how do I know this? It's by looking at the map.json export, and then here you can have, for each layer you have a name key, the name key. This is how you know which name a layer has, if they have any. All right, so if I go back to main, I have the layer.name equal boundaries, and then if we're going to need a for loop, which is going to iterate through all the boundaries of layer.objects. Remember that when you're dealing with an object layer, which is the case for the boundaries, they have access to the objects property, which is an array containing all the objects in that layer. And the objects in that layer are just objects with x, y, and width and height properties as well. And now here we use the map object, and then we add another game object to it. So we can have child game objects by taking an existing game object and using the add function method on it. So what I'm going to do here is I'm just going to copy and paste it. It's going to be faster, and then I'm going to talk over the code. So we have an area component with a specific shape that corresponds to the width and height of the boundary itself. This comes from the tiled export in map.json. You see each object has a width and a height. Maybe we created this needlessly because the width is 0 and the, okay, no, never mind. Anyway, so you have your objects from here. And then I specify the specific shape we want, which is a rectangle, and you can do this by calling the making a new instance of the rect class. And then here you have as the first param the coordinates of that hitbox relative to the game object we're creating. We're just gonna pass in an empty vector. That means we want the rectangle here to be at the same position as the overall game object. So yeah, the child game object, because it's different. Then there's the position of the game object itself, and then there's the position of the hitbox, so the area for that game object. And here, by setting the vector 2 to being 0, that means we have the exact same game object, game position, sorry. And then finally we add the body tag. This is important so that we can add the isStatic property. What it does, it basically makes sure that the only way, that means that the player will not be able to pass over it. So it's going to be really stuck in that, yeah, it's going to be, how do I say? The player will not be able to overlap, and this is how you do walls in Kaboom.js. And then finally we pass in the name of the object, which was defined in the tiled export. This gives us the tag. It's going to act as the tag of the game object. This is how we're going to be able to identify what the game object is, what the boundary is. And this is going to come in handy later on because we're going to be able to know what to do when the player collides with it. Now that we have this, right below, if the boundary name of that specific boundary that we just created in Kaboom.js. So this, we're just taking the name out of the tiled export because we want to do something different. So if we want to actually here set the on collision events. So if the player, we have the on collide method on the player because we use the area component when creating the player. We're going to do boundary dot name. So the first param of the onCollide method is the tag of the second game object you want to check collisions with. We want to check the collisions of the player with this game object with the following tag, which is boundary.name. And then here we have a function that is going to run as the second param when, yeah, so it's going to run when there is when the collision occurs. And here we're going to set the player property is in dialog to being false, true actually, so that we're going to later on be able to prevent the player from moving while the text box is being displayed. And then here we're going to write this is actually where we're going to write the dialog, display the dialog, sorry. So is in dialog is here, it's from here. And then now if I go to, so let's put a to do here, to do. And let's go to utils.js, and in there we're going to create a new function that is going to take care of displaying the dialog. So export function display dialog, and then the first param is going to be the text, and on display end is going to be a method we're going to pass. Whoops. A function, sorry, that is going to run when the text is finished displayed. So we need two things. We need to get the dialog UI, which is basically the text box container. So I'm going to do document.get element by ID, and then text box container. All right. Once this is done, let me look if we have actually the markup for it. We don't. So let's go first create the markup for it in HTML. So here we're going to have, first of all, inside of the div, the UI div, we're going to have a p tag. That p tag is going to have the class of note. We're going to later on create the CSS for it. And basically it's just an instruction to tap and click around to move. Now that we have that, I'm going to create a div within, and this is going to be our actual dialog UI. So I'm going to give it an ID of text box container, and then the styles here, we're going to actually, this is not a really good practice to do if you are in making a website, but I'm gonna use the style tag here for a specific thing, for the display, setting the display to being none. You could have just created an ID here, a selector here, but because I'm gonna change this through JavaScript, I'm going to use this. But actually, I think you could just use a class list or something like that. So I create a class and then I remove it. But you know, for this project, I'm just not gonna bother with that. Okay, so now I'm gonna create another div from within. This div is going to, whoops. So let me do this. Maybe I should increase the font size a bit more. Yep. So the div here is going to have the class of button, actually text box. It's going to actually be the text box itself. And from within, we're going to have a p tag that is going to contain the text, and I'm going to give it the ID of dialog. And then we're going to have a class for it as well, which is going to be UI text. And later on, I'm going to fill those in. Right below, we're going to have another div. And then a button. The div is going to have a class of button container. This is so we can create a container where the button is always going to be on the right side of the screen. I'm going to give an ID to this button to being the close button when the player wants to close the text box. I'm going to give it the class of UI close button. Now let's write the CSS for it as well, since we're here. I'm going to load our font. So in Kaboom.js, you can load the font if you want to display it via canvas. But because we're displaying via HTML the text, I'm just going to use the CSS for it. So font family, monogram, that's the name of the font. And then the source for the font is URL. And then it's monogram.ttf. And now it should be able to find it out here in the public folder. Okay, now the body tag, let's style the body tag as well. This is just going to set the font family for all of the body tag to using monogram, or as a fallback, you're just going to use monospace. So monospace is a font that should be already in your browser by default. The font size by default is going to be 2 rem. So 2 rem, 1 rem is basically the size of the font of your browser set by default at the root. So usually it says 16 pixels, and then you can decide, you can zoom in and zoom out in your browser control. So it takes the font size and multiplies it by 2. So 2 times the font of your browser, so that it will adapt. It's going to be responsive by default. And then here, I'm gonna do overflow hidden. So here, instead of having overflow hidden here, I'm just gonna put it in the body so that the scroll bars don't appear. And then however, in the app selector, all of this is going to have a position of relative. This is so we can position it precisely with the X left and specifying the left and the top left and the right and bottom, etc. So that we can, it's going to, how do I say it? It's going to leave the document flow, and we're going to have much more granular control of where to put it. It's like if you would put an element on the canvas, you really control the X and Y position of that element you put in the canvas. So this is basically a way to achieve the same thing in Kaboom.js, in CSS, sorry. Now let's add for our, wait a minute, we have the text box. I don't think this is, I made a mistake. This should be an ID and not a class. And now below here, we're gonna have the class of text box, the ID, sorry, of text box, the selector for it. And here by specifying position absolute. This is where you actually get the full control of where to put it by using the left property. I'm gonna put 10%, right at 10% as well. So it's gonna look good. I'm gonna put the bottom at 2 view height. So it takes the view height and then it's a measurement relative to the view height. So it's going to adapt regardless of the screen of the user. The minimum height we're gonna need is 10 view height. This is what looked good. This is for the text box. You're gonna see in an instant when we'll see the result. The background, so this is the color of the text box. Let's put it white. Okay, so we have the background. The border radius, I'm just gonna put 3 pixels, it doesn't matter. The outline style, it's going to be black or solid. Is it the color? Yeah, solid. The padding is going to be 1 rem. As I explained, rem is based on the font size of your browser. And it makes it responsive, basically. And then, what do I need? Display flex. We're going to create a flex container. Now, this is some CSS knowledge. I assume that you have it. You have this knowledge already. If you don't, read up on flex containers. There are plenty of great articles and posts online explaining everything. So we're gonna have display flex and then a flex direction of column. So the children of our flex container are going to be positioned in the column. We're gonna set the flex wrap to wrapping so that when there's no space, it moves on to the next row. We're gonna justify the content to being flex start. This is so that the text within the text box starts at the top left corner. Align items as well. I'm gonna do flex start. I think I always mess up the justify content and align items. One is for the axis for which the content is flowing, and the other one is for the cross axis. So for both of those cases, we want it to start at flex start, which means it's top left, and yes, so it's top left basically. And then play with those values as you're gonna see how they are affected. Then word spacing is going to be 0.2 rem. This is what looked good. So word spacing is self-explanatory, so the words appearing in the text box. And then here we're gonna have a little drop shadow. So we're gonna have a filter and then a drop shadow with the following arguments. Rem and then a color RGB. So this is really took straight from the MDN documentation with just a bit of tweaking in terms of colors. Yeah, I don't really know. Maybe there's some explanations here. Yeah, you have drop shadow here. So here it is explained where are the params? Where are they? Does it explain? Okay. Okay, it's in French, by the way. Anyway, you're gonna figure it out by just looking at the docs, MDN docs. Type in drop shadow CSS, you're gonna understand. All right. Now, the UI text class gonna have a margin of 0, and then user select none. This is important so that the player cannot select the text and highlight it like that. Usually you don't do that in a game. And then finally, you have, actually there's a couple of selector to define. So UI close button. I'm just gonna copy what's left. It's not much, and I'm gonna go over it. So UI close button uses this font family. For some reason, you need to specify this, otherwise it doesn't use the font, and I'm not sure why. Border style none, border radius 3 pixels, some padding, and then it should inherit the font size. Actually, maybe you could do inherit here as well, and it should work. And then button container, it's going to align itself at the end of the text box so that the button is always going to be appear at the top right corner. And then the note is going to be, again, position absolute. It's going to be at the top left corner. So left and then top one VH. Display flex direction of column, etc. And then this is the color of the text. It's going to have that color. Yeah. If I save everything, look at the result, you can see that here you have tap, click around to move. Here it doesn't matter if you can select or not. But for the text box, we don't want you to be able to select the text. Actually, you know what? Let's also put it as user select none, just to make sure that it looks like a game. And that's it. If I now try to select, I cannot. You see. All right, now we have this. We can simply go back to our utils.js and write the rest of the logic we had here. So we need the following. So I'm just going to copy and paste that here. So we get the text box container, we get the dialog. So the dialog is actually the p tag here, where we actually put the dialog in. And then what we're going to do is we're going to set the display. So initially, remember in our markup, I put style display none. This is to make all of this invisible by default. When we want to show the dialog, we can use the style attribute here and set the display to being block, and this is going to make the text box container visible. So which by extension means that the dialog box is going to appear and the text is going to be visible. Now we're going to implement text scrolling, and this is very simple in HTML. This is the code for it. So I create an index which I set to 0, and then the current text is going to contain the text we're going to add to the element, the inner HTML here of the dialog box. Now inner HTML is not really recommended to use because you can be victim of cross-site scripting. So here in our particular case, it doesn't matter because we're not accepting user input. So it should be safe to use inner HTML, and it's kind of required because when we want to have our dialog box, you're gonna have sometimes the text that appears with links to your GitHub or things like that as attributes tag. And if we were to use inner text, for example, then those attributes that we pass, the links are not going to be rendered as links and will not be clickable. So here we use the set interval function in JavaScript. This is something that is basic, like vanilla JavaScript, and every 5 seconds it's going to run the function here. We put a reference to that interval, that set interval event, so that we can cancel it, clear the interval when we're done with it. And then as long as the index is inferior to the text.length, so text.length is the text that we pass here, then we take our current text, we append the specific character at that specific index of the text, and then we put it all in the inner HTML. And and then we do index plus plus, and then we skip this until the condition is no longer true, and then we clear. And that's basically it. Now we need to write the logic to have the onClose button, so that when the button needs to be closed, to do something like that, I'm going to put this outside, but still in the display dialog function. So if I paste, we get the close button by using a simple get element by ID. And then I create this function called onCloseButtonClick. It's going to call the onDisplayEnd function. This is useful because in this function, we're gonna set the player is in dialog attribute to being false without having to pass the player to this method, this function. So this is a handy way of using passing a function from the outside that has access to the player object, so that we don't have to add a third param here. And it doesn't make sense really. Why would you need the player to display the dialog? So that makes much more sense, and it's much more extensible. For example, if you want to do other behaviors when the display is over, ends. And then here, the dialog UI style display, we put it back to none, so that the dialog section of the UI is going to be invisible. We set the inner HTML back to being empty. This, you could have used inner text, it doesn't matter. And then we clear the interval if it's not yet the case. And then we remove the event listener because we're going to add it. Okay, so we remove the function itself within the function. So it's recursive. So here we have, at the end, we create the event listener when there is a click, and then it runs this, and then it removes itself as the event listener. So that's it. Now if we go back to main.js, we can, here in the to-do section, have player, not player, call the display dialog function. It's going to import it automatically. Actually, it should automatically import it from the utils file. And then here, I'm going to pass the dialog data. So here for now, let's put test or to do. That's our text that we're going to display. And then here, we're going to have a function. And this function, actually, its role is just to set the player is in dialog to being false, so that the player can move again. And yeah, so look at the code here. And that's it. So if I think I have it, I collapse this. And then if, however, so we should probably put a continue at the end. So here, after all of this, we continue. That means we skip to the next iteration of the for loop. And then here, if the layer, the layer.name is the spawn points, well, the spawn points layer, which is where the player spawns, we're just gonna have for const entity of layer.objects. There's just one entity, but I'm writing the code to be generalizable, so that if you decide to put more than one entity in the tiled export, it's gonna still work. And then so if entity.name is equal to the player, so this is going to be the player, so that's this is the name. I'm gonna put player.position because I added the positional component when creating the player game object, despite having set it up to nothing. I can access the attribute position and set it manually after having created the game object. And here I'm going to use a vector2, which is just the x and y coordinate. And the position we're going to use, though, it's going to be very specific. It's going to be, whoops, not what I wanted to do. Yeah. So we're going to take the position of the x coordinate of the map. You do this by accessing the pause property and then the x coordinate. And then we're going to add the entity.x, which tells us where to place the player. And we multiply this by the scale factor, because remember, we're basically multiplying everything by 4 so that everything is nicely visible and big enough. Same logic for the y coordinate. And then finally, here we use the add function in Kaboom to add the player game object we created in the scene. And then here you can continue, or it doesn't matter because we only have like 2 layers or anyway. So now that we have all of this, it's time to, just gonna collapse all this section. We're done with it. And then here I'm gonna, I think that's right. Just some code to make the camera follow the player. So by default in Kaboom.js, you have the camera object already created. You can call the cam pause. So the camera system already exists. You can just control it. So I'm going to take the player world position. The reason we're using world position instead, actually it doesn't matter really because we haven't created the player as a child object. So if you're creating a game object as part of a child of another game object, you use world position to convert its position to being the position of in the actual canvas and not relative to the parent. So here I'm gonna use player.pause.x and then player.pause.y plus an offset of 100. So this cam pause is going to set the camera position to being this in the x coordinate and this in the y coordinate. Now if I look at the result, okay, I have the character, but the map is not appearing. I'm wondering why. Actually, why is the map not appearing? Is it doing everything right? Wait a minute. So if I go back to the top where we created the map, we have, okay, I haven't added it to the canvas, but you know what? Because it doesn't matter, let's use add instead to immediately add it to the canvas. And here we go. The map is displayed. If I press F1, you can see all the collisions. And for the specific objects, you're going to have TV, sofa table, PC, resume, project, exit, etc. Now the player cannot move. So let's fix that. And then also we're gonna need to add some other stuff like setting the camera scale. So depending on if the player is using a small screen or a big screen, we want to make the camera zoom a bit or not to compensate. So here, so let's actually write the logic for moving the player. So I'm going to use the k.onMouseDown. So because this is a very simple project compared to other tutorials I made, I'm not going to write those methods inside of the player. Let's just use the onMouse and take the player game object directly here. And yep. So when the onMouseDown is an event in Kaboom.js, it takes in a function and it will pass to it the mouse button that is currently being pressed. On mobile, it's just gonna consider a tap basically. And then here, if the mouse button is not equal to the left mouse click, or the player is in dialog, then we return early. That means we do nothing, we don't move. And this makes sense because we don't want to allow the player to move when a right click is pressed instead of a left click, because if they press both at the same time, they're gonna move twice as fast. It doesn't really matter because it's not a game we're building really, but just so you know. And here, if the player is in dialogue, of course, we don't want to allow the player to move while they are in dialogue. We want them to focus on the dialogue. Okay. Now for movement, we're going to need the following snippet of code. So let me just, okay. So that's all there is to it when it comes to movement. We need the world mouse position. That means because we're using the camera, the mouse position is going to be really according to the canvas and not according to the world. The world can be much bigger than the canvas because the world is much more than what is visible by the camera. And when you drag around, this what happens is that if you use the k.mouse pause, the mouse position directly, you're gonna at some point get stuck. I wrote a blog post article on my Substack. Link is in the description, so feel free to read it to get a better understanding. And by the way, subscribe to my Substack if you want for more like written content. Yep. So the only thing we need now to move the player is to use the move to function that is available on the player, because we have the, I think, the area component, the body component. I think because of the body component. So some certain methods in Kaboom.js are only accessible once you have added certain components when creating that game object. So the first param is what is the target position you want, and we want the world mouse position. So we want the player to move towards this at the specific speed. And here we just get the speed from the player, which we defined here. All right, now if I look at the result, we should be able to move. And here we go. And then you can see we collide, and then to do, there's nothing that appears. And then to do again, to do. We haven't written the content, but that's almost all there is to it, you know. The next step is really to code the direction, the various directions. So make the player face a different direction, scaling the camera according to the device being used, the resolution. Otherwise, sometimes it's too big. It becomes too big. And actually putting the content inside of those text box. And that should be it. So now let's actually write the logic for scaling the camera, and then we'll write the logic for the directions, and then we'll add the text, hopefully in that order. So here for the camera scaling, I'm just gonna, in the utils.js, we're gonna create another function right below, export function set cam scale, and then here we just pass the context so we can know, we can compute how much we need to scale. So here I'm gonna create a constant. I'm gonna call it resize factor, and it's gonna have access to the width of the canvas. You can have access to the width of the canvas by calling the width method on the Kaboom context, and the height as well. And then we have this division to get a factor, and then if the resize factor is inferior to 1, that means we will simply set the cam scale. This is a Kaboom method, to being just 1. You can also do 2vec1, which is just gonna set it to 1. Otherwise, an else statement. You could either have an else statement, or if you want to be fancy, you can, and more clear, you can have an early return. And then here, right below, you can have k.cam scale, cam scale, and then k.vector2, and we increase the scaling, so we zoom by 1.5 in both x and y transformations, so 1.5. All right, so now we have this. I'm going to go back to main, and where we're going to call it is, we're going to call this function first in 2 occasions. The first one at the beginning, we just do set cam scale, and then k, and also every time we resize the canvas. So you can know when this happens by using the onResize Kaboom method, which takes in a function that is going to run when this occurs, and then you just can call the set cam scale, and then pass in the context here. So let's look at the result. So here you can see everything is much better, and then as you decrease the thing, it's smaller, I think. Or is it? Let's take an iPhone SE, and then let's yeah, it seems to relatively work. Maybe I'm not sure. Let's gradually. Yeah. All right. Yeah. So it does. Yeah, it does change. Okay. Sounds good. Now what we need is to basically display the correct animations and sprite depending on the direction. So what I'm going to do to be able to know when the player should be facing left or right or any of those angles is to first store the mouse angle, which is just going to be the angle between the player. So you can do that by using the angle method of the position of the vector of the position of the player. So player.pos.angle gives you this, and then you can pass in the world mouse position, and it's going to be give you the angle between. And with that, I'm going to first specify a lower bound, which is going to be 50, and a upper bound, which is going to be 125. You're going to see in an instant why we need this. And then we have our if statement. So here I'm just going to copy and paste and talk over it. So first condition, if the mouse angle is superior to the lower bound and inferior to the upper bound, and the current animation isn't walk up, then we will play the walk up animation and set the player direction to be up. If I look at the result, it's when the mouse is here. Imagine that you had a circle, and then here, if your mouse is within a certain range, actually for now you're not going to see the difference. So let's say my mouse, the angle here and here, so you're on the circle. As long as my mouse is still within those position, the up animation is still going to play. However, if my mouse exceeds, for example here, we shouldn't. Now this is not very clear for now, but let's add the conditions and then you'll see. So now what comes next is for the down animation. So it's the same thing with negatives instead. So now if I run and look at the result, if my mouse is here and I click mouse down, that up animation is going to play. If my mouse is here, the down animation is going to play. Now if I do, whoops. Okay, let's whoops. Okay, let's say I'm here. So if I do this and then I change, you see, it dynamically changes as long as I hold the mouse, because now the mouse position is within those upper and lower bounds of this imaginary circle in terms of angles. So now I'm just going to add the two other conditions. This is for the left and right, and then here, right below. So for the right, we take the absolute value of the mouse angle, and as long as it's superior to the upper bound, we flip the player X to being false. The flip X is useful because we only have one animation for the walking. It's called walk side, and by default it faces to the right. That means that if the player was flipped, mainly because of the other animations where we do flip, so for the left side, then we put it back to false so that the player looks at the correct direction. And then here, the same thing, but with flip X being true instead. And as long as the mouse angle is inferior to the lower bound, the absolute value. So we don't care about whether or not it's negative or positive, etc. So this is so it works on both sides of the circle, the imaginary circle. So now if I look at the result, you see, and you can have directional movement like that. Now you see that the animations of the player never stops, right? The way to go about that is to use the on mouse release method in Kaboom.js. I'm gonna paste it right below. So here, let me collapse everything here. And yeah, on mouse release. If the direction is down, we put idle down. If the direction is up, we put idled up. And if it's neither, then we put the idle side. And because we flipped the player, it's gonna point towards the correct direction by default. We don't need to do anything. So if I look here, I do this. Here you go. And then here, like that. And then I release the mouse, and then the player stops. And that's basically it. Now the only thing is really the content here. And what we're gonna do here for that is I'm going to go back to where I think it was here. When instead of having to do, we're going to hold the content of our dialogue inside of a constant. I'm going to just call dialogue data. Let me just look it up. So I'm going to copy and paste it and just explain to you how it works. And then you don't have to use the same text. So here you have a dialog data object with keys that corresponds to the tag of the boundary. So for the PC, you have this text, and then you can see me using the a tag here to have links, etc., as if it were HTML. And now here in main.js, instead of doing this, what you do is just you get the dialog data constant from the constant file. So it should import it automatically. Otherwise, do it manually. Here it is. And then here you just pass in the boundary name to select the correct text to display. And that's basically it. The project is done. If I go here and I go here, if you want to exit JS Legends portfolio, just close the tab. And then here, that's my TV. I've been watching tech YouTubers a lot recently. The Primeagen, Theo, Pirate Software, Milky, etc. And then here, that's my sofa. I like to relax and etc. And then you get the point. So if I open up the debug mode, you can see when there's the PC key here, those are the name of the various boundaries, and this is how we use them to as keys for our dialog data. So here, for example, this is my desk. On it is my resume. Check it out, and then it's a link with an a tag. So here, if I go here, the a tag, where is it? Constant. You can see the link to my resume, etc. So this is you're free. Don't just copy what I wrote here. Write your own dialogues to tailor it to yourself, basically. And that's basically it. Thanks for watching this tutorial. Hope it was something that you like to learn about. And yeah, thanks for watching. Feel free to subscribe for more content related to game development, specifically JavaScript or web-related game development, but hopefully not only. Maybe I'll try to do other types of development or with other stacks. So maybe making games with Lua or some stuff like that in the future. So yeah, feel free to subscribe and share this video if you found it useful. All right, thanks for watching. Bye.